Hi everyone. In this lecture we're going to be looking at section 6.1, which is basically solving a right triangle. So what we're going to do is have a new naming convention, so a new labeling convention for angles and sides. From now on, angle A and side little a are going to be opposite. Capital letters are going to be angles. So capital B and little b, capital B is angle B, small case b is the side opposite angle B. Angle C is a capital C, side C is the side opposite. And in this section, angle C is still a right angle, a 90-degree angle. In the next several sections, angle C will not be a right triangle. Okay. To solve a triangle, that means we want to find every angle and every side for that triangle. Let's start with you. Okay. So the procedure for solving a right triangle is if we know one even of the non-right angles, then we know all of them. Well, why is that? For instance, if we know A, C is given, how do we know B if we know A? Exactly right. We know that A plus B plus C is 180, but we also know that C is 90, so if I subtract 90 from both sides here, I get that A plus B is 90 degrees also. So the sum of A and B is 90 degrees and C is 90 degrees. We're going to use this fact quite a lot. If we know two sides of the triangle, we can use the Pythagorean theorem to find the missing side. And if we know one angle and one side, we can use a trig identity to find another side, and then once we get two sides, we'll be able to find all of the sides. Okay, so let's start with an example where we've got the legs of a triangle are 15 and 8, and the angle theta is opposite the side of length 8. We want to find the 6 trig functions for theta. And I think this question is the last theta question in this section. So it's kind of a nice, we're fond of theta. So here we go. We know that 15 squared plus 8 squared is c squared. So let's see, 225 plus 64 is c squared. And if I add those up, I get 9, 8. So c squared is 289. Since I've got a regular right triangle, not something inside of a coordinate axis, but just a right triangle, when I take the square root of both sides of this equation, I do not have to put a plus or minus. I do not have to. It's not wrong to do that, but we don't have to. And this is one of our friendly triangles. I know that 17 is going to be C. So we want to write all the trig functions for the angle theta, and now that we have all three sides of the triangle, we can do that easily. Sine is opposite over hypotenuse, so 8 over 17. Cosecant is the reciprocal of that, 17 over 8. Cosine is adjacent over hypotenuse, so 15 over 17. Secant is the reciprocal of cosine, 17 over 15. Tangent is opposite over adjacent, so 8 over 15. And cotangent is the reciprocal of tangent, so 15 over 8. Now let's do something a little bit more fun. Let's solve a right triangle if we're given that the measure of angle B, let's go ahead and explain this notation. That little m stands for measure, and the angle just stands for the word angle. So when we talk about the value of an angle, how many degrees or radians it has, we usually put this little measure and an angle symbol. And we'll do that definitely in this chapter 6. So I know that the measure of angle B is 52, and that side A is 11. And I know where angle A is once I label side A. So let's see, side A and angle A have to be opposite. Side B and angle B have to be opposite. Now, can I easily find angle A since I know angle B and I know angle C? It's exactly right. We know that A plus B is 90. And we already know B. So if we subtract 52 from both sides, we get that the measure of angle A, let's see, 10 minus 2 is 8. 8 minus 5 is 3, 38 degrees. Yes, okay, great. So we know that the measure of angle A is 38 degrees. And let's keep going. We want to know the 3 sides, and we only know one side so far. So gosh, let's figure out a trig function for either of these angles that involves the side A and only one other side. So how about we try this? Let's do the sine of B. Well, the sine of B is opposite over hypotenuse, but from the point of view of, oh no, we don't want to do, okay, we want to do cosine of B because we want to involve side A. So from the point of view of B, A is adjacent, C is hypotenuse, so we get A over C, and we can figure this out. Cosine of 52 degrees is equal to, let's get our handy dandy calculator. And for these problems, I just use my my phone calculator. And if you take your phone calculator and turn it sideways, you'll get a scientific calculator. And the way mine works anyway, if I'm using radians, like if I'm using pi units, I have an RAD up there. If there's nothing written up there, then I'm using degrees. So I want to type in 52 degrees, and I want to take the cosine. So I get 0.6157. For sines and cosines, tangents, everything like that, we're going to round to 4 decimal places. So we get that the cosine of 52 is 0.6157. I'm going to round to 4 decimal places there. But we know that this is also equal to A, which is 11, over C. And now let's multiply both sides by C. So that we get C times 0.6157 equals 11. And now if I divide both sides by 0.6157, we get C. So let's see. I've got 11 divided by 0.6157 0.157. So I get that side C, it has length 17.9. For links, for links and for angles, we're gonna round to 1 decimal place. So this is approximately equal to 17.9 units, whatever the units are. So we've got 17.9. We can find side B 2 different ways. We can find side B by taking the tangent of 52, because tangent is opposite over adjacent. Let's go ahead and do that. That sounds fun. So we've got the tangent of 52 degrees is opposite over adjacent. Opposite is B, that's what we're looking for. Adjacent is A. We have that already. Now if we multiply both sides of this by 11, we get 11 times, let's see what the tangent of 52 is. So I'm going to tap in 52 and then tap tangent. I get 2799. I'm rounding to 4 decimal places. So 1.2799, that's going to be B. So 2.1799, 1.2799 times 11, and I get that B is 14.0789, but I want to round to 1 decimal place, so 14.1. And B, all of these links are just units. So we've got B is 14.1. And now to check, I can use the Pythagorean theorem, because it's really nice. So I know that A squared plus B squared will give us C squared. And we got 17.9 for C. A was 11. And B, we just found 14.1. And since I'm checking, I'm not going to put an equal sign in the middle here. I've got 11 squared is 121. And I do not know 14.1 in my head. So 14.1 squared is 198.81. And 17.9 squared is 320.41. And now let's add 198.81 plus 121. 198.81 plus 121. We get 319.81. And we still have 320.41 on the right. And these are definitely close enough. Why aren't they exactly the same? Why don't I get exactly the same number on both sides? Yes, that's exactly right. We're rounding all over the place. So we've decided from the beginning to round, let's put it up here. Round trig values to 4 decimal places. Round sides and angles to 1 decimal place. Okay, great. Oh, I did something this time a little different. I made a separate document with group work. So the first two group problems are on the screen right now. There's the group problem. We have a triangle with legs of 12 and 5, where 12 is the side opposite theta, and we want to find all the trig functions for theta. And then example 4, you're given that the measure of angle A is 20 degrees and that the length of A is 5.2 units. And we want to find, when it says solve, it means find all the angles and all the sides. So we want to find B and C and angle capital B. And we'll pick this example 9 up in a second.
Then why Apple kept this M1 MacBook Air in the light.
Okay, great. So now we've got a right triangle. We're given that side A is 10, side B is 12. Oh, we don't have any of the angles except for the right angle. So how can we proceed? Well, yes, certainly we can find C easily enough. We know that C squared is A squared plus B squared. That's 10 squared plus 12 squared. That's 100 plus 144. What is that? 244. And again, since this triangle is not in a coordinate axis, we do not have to put a plus or minus. You can, it's okay, certainly okay, but we don't have to. Now let's see, we've got 244, handy dandy calculator. So 244 square root. And I get 15.6. How do you think we can find these angles? Because let's just start with A. Do I know that the sine of angle A, let's see, sine is opposite over hypotenuse. And I know both the opposite and hypotenuse. So let's see, the opposite side is 10. The hypotenuse is 15.6. Let's see. Okay, so I've got 10 divided by 15.6. That's equal to, since this is a trig value, I'm going to use 4 decimal places. So 1, 2, 3, 4. The number to the right of the fourth digit is a 2, so I'm going to leave the fourth digit as it is. 0.6410. Oh, but wait, how can we find, we don't know the angle, but we do know about inverses. So I'm going to tap in 0.6410, and this is how it is on my calculator anyway. I put second, and now I've got these inverse trig functions. So I'm going to tap inverse sine, and I get 39.9. I'm rounding to 1 decimal place. The number to the right of the 8 is a 6, so I'm going to bump the 8 up to 9. So I get that A, the measure of angle A, is approximately 39.9 degrees. Let's find the measure of angle B the same way and then see what they add up to as a check. So let's see, we've got angle B here. Is there a trig function that only involves the B sides B and A? Absolutely, exactly correct. So we know that the tangent of B, that's opposite over hypotenuse. The opposite of b will be little b, that's 12. The adjacent. Thank you. The adjacent is 10. And this is kind of easy. 12 divided by 10 is 1.2. So I don't have to round there, but I'm going to go, I still have my second function on, and I see inverse tan. So I get that b is 50.1944, but I don't really want all those decimal places. I just want 1. And if I look to the right of the 1, I get a 9. So I'm going to bump that 1 up to 2, so that b is approximately 50.2 degrees. And now let's add a and b and see how close we are, because we know that a plus b should be 90. So we've got 39.9 degrees plus 50.2 degrees, and I think it's going to be nice. 39.9 plus 50.2, it's 90.1. Very good. So we're lots and lots of checking built into these problems. All right, more definitions. The angle of elevation. Elevation and depression are both with respect to someone, an observer. So I put an I. So from the point of view of this observer and that observer's horizontal line, the angle of elevation is the angle up to an object. The angle of depression is the angle down to an object. And that's really all it means, that if you have an angle of depression, then the object that you're looking at is below the horizontal. If you have an angle of elevation from the point of view of the observer, the object is above the horizontal. When we're looking at applications of right triangles, it's really important to draw a sketch of the situation and label every single thing involved that you do know. Find the missing sides and angles, and then answer the original question. Answering the original question is super important, because it's not always just automatic. Okay, so did I miss? Let me see something. We are at 5. We skipped to 10.
Even though you have waited and
well, before we do 10, here's a problem for y'all to do. I think my numbering sequence is off, that's all. So, example 9, solve the right triangle given that side A is 9 units and side B is 8 units. All right, great. Now let's look at the situation. A child flies a kite on a windy day. He holds the spool of string at a height of 4 feet above the ground, and he notes that the string makes an angle of 42 degrees from the horizontal. Yes, he loves math. If 120 feet of string is out, and the sag in the string is negligible, which means we're not going to worry about sag, find the height of the kite to the nearest foot. Then find the horizontal distance of the kite from the child. So first we're going to find little a and little b, but little a is not the answer to the first question. The answer to how high the kite is will be little a plus the child's height, 4 feet. All right, so we've got one side and an angle. What do I know? What trig function of this angle A, the lower angle, would use one of our missing sides and the hypotenuse. Absolutely, sine is perfect. So I know that the sine of 42 degrees, well, that's opposite over hypotenuse. Opposite is A. Hypotenuse is 120. And let's find the sine of 42. So we've got 42. Turn this off. Sine. And I get 0.66913. Since the number to the right of the 1 is a 3, I'll leave the 1 as it is. So we get 0.6691, and that equals A over 120. Now let's multiply both sides by 120, so that on the right we've got A, and let's see what we have on the left. 120 times 0.6691. I get 80.292, so I'm going to round it to one decimal place. 80.3, and that's in feet. So little a is 80.3 feet. And let's find little b. I'd like to still continue to use my angle A because that was what was given. The more I use the given information, the less likely it is that some mistake I make will affect additional questions. So what trig function of A involves an adjacent side and the hypotenuse? Exactly right. We know that the cosine of 42 degrees is adjacent over hypotenuse. The adjacent side is B. The hypotenuse is 120. And let's see what the cosine of 42 is. Let's see, cosine. 0.7431. The number to the right of the 1 is a 4, so the 1 will stay. So I get 0.7431 is equal to B over 120. And I want to multiply both sides by 120 to get B alone on the right. And let's see, 120 times 0.7431, I get 89. I'm rounding to one decimal place, so I'm going to round to 89.2 feet. I round up to 2 because the number to the right of the 1 is a 7. 7 is 5 or more, so the 1 becomes a 2. All right, so now we've got the three sides of this triangle, 89.2 feet and 80.3 feet. Let's answer the question that was originally given. Oh wow, they wanted the height to the nearest foot. So we should round this to the nearest foot. So this will be 80 feet. And this will be 90. Oh no, this will be 89. It's because 2 is less than 5. Okay, so we've got 80 feet and 89 feet. I want to check really fast. I want to see if a squared plus b squared is c squared. So we have a is 80, b is 89, c is 120. Let's see. 14400. And 80 is going to be 6400. I do not know 89 by heart. 7921. So it's a plus 6400. We get 14321, and this is close enough. The reason that our values are not more exact is that we rounded to the nearest foot. Excuse me, which is reasonable in this kind of problem. So, but we know that our answers are in the correct ballpark. So, they originally asked the height of the kite to the nearest foot. So we know that the kite is 80 feet above the child, and the child is 4 feet, or the child's hand is 4 feet above the ground. So the height of the kite will be 4 plus 80, or 84 feet. The distance away from the child is going to be B. So 89, that's the distance, horizontal distance. Okay, groovy. The next example, from an eye level of 6 feet, an observer standing 30 feet away from a building sights the bottom of a window at an elevation of 6.1 degrees. So that means that the window is above her, and it's an angle of elevation, it's above, and the horizontal is her eyesight, her eye level. So with respect to her eye level, we're going 6.1 degrees up, and we get to the bottom of the window. She sights the top of the window at an angle of elevation of 20.1 degrees. So from the horizontal all the way up to the top of the window is 20.1 degrees, and we want to find the height of the window. So I've labeled several things in here. Let's draw this triangle here. So we have several things going on. We have 6.1 degrees. Then we have 20.1 degrees. We also know the base is 30 feet. And I've labeled the height several letters. So I'm going to call this entire height A. And the part that we're looking for, X, and this other segment, Y. Because then I'll know that X plus Y equals A. And now I'll have a name for every part of what I'm looking for. Ultimately, what we're looking for, though, is X. X is the height of the window. Well, let's just look at this small triangle. We have 30 feet and 6.1 degrees, and we want to find the opposite side. So what trig function involves adjacent and opposite? Exactly right. So we're going to take the tangent of 6.1 degrees, and we know that that is opposite over adjacent. And let's see. Come on. So we have 6.1 tangent 0.1068, but if I look to the right of the 8, I have a 6, so this is going to be 0.1069. And that equals y over 30. And it's really important when we're rounding things like this, not to use the exact value that we have in the calculator, but type in the rounded value. So 0.1069 times 30. So we multiplied both sides by 30. And we get that y is approximately 3.2 feet. Oh, great. Now let's look at the bigger triangle. We still have 30 feet in as the base. Now our angle is 20.1 degrees, and the opposite side, I'm going to use the letter A, the whole distance. And the trig function that involves the angle at the base here, the adjacent side, and the opposite side is tangent. So I know that the tangent of 20.1 degrees is A over 30. Let's see. 20.1 tangent 0.3659. Okay. 0.3659, and that's equal to A over 30. If we multiply both sides by 30, so I don't want to multiply this number by 30. I want to delete this number and type in 0.3659. 0.3659 times 30, and we get that the length of side A is 10 point, we're rounding to one decimal place. We have a 9, 7 is larger than 5, so we're going to bump the 9 up. So this is going to round up to 11.0. So A is equal to 11.0 feet. And how can we find the height of the window? X. Well, yes, exactly right. We know that A is equal to X plus Y, and that's the main reason why I put all those labels, so it would be easier to figure out how to solve for X. So X is, we have to subtract Y from both sides, and let's see, A was 11 feet, Y was 3.2 feet, 11 minus 3.2 is 7.8. X is equal to 7.8 feet. So the window has a height of 7.8 feet. Wow, this is fun stuff, huh? Let's see, there's some more questions for y'all. So question 11, a 40-foot ladder is on a fire truck. It leans against a burning building so that the top of the ladder makes an angle. So there's a building here, we're pretending. The top of the ladder makes an angle of 20 degrees with the building. If the bottom of the ladder is anchored to the top of the fire truck 6 feet off the ground, how far above the ground does the ladder reach? So is the answer going to be this opposite side, well, this height of the triangle? And we want to round to the nearest tenth. Okay. An airplane begins its descent at an average speed of 200 miles per hour and at an angle of depression equal to 15 degrees. So this is the value they gave us. With respect to the horizontal, we have an angle of depression, so it's down from the horizontal, But there's this geometry stuff that we kind of know from a huge long time ago. If you have parallel lines, and we have a line that cuts, and we know an angle in the upper left, then we know that the lower right is also going to be that same value. So that's how we know that the lower angle of the triangle is 15 degrees also. Okay, so let's see. The plane is flying 200 miles per hour, 15 degrees down. Find the number of vertical and horizontal miles to the nearest tenth of a mile that the plane will cover in 3 minutes. Well, that's cool. So they give us miles per hour, but the information is asking about minutes. So I'm going to write down 200 miles per hour, because MPH makes it harder for me to remember what to do with hours. And I want to change this to minutes. This tells me that hours needs to go in the numerator and minutes needs to go in the denominator. Now the hours will divide out, and let's see. Come on. And we have 200 divided by 60, and that's 3.33, etc. And we're rounding to 1 decimal place. So 3.3 miles per minute is the rate that the plane is flying with respect to minutes. And that makes it easier for us to see how far it will go in 3 minutes. So in 3 minutes, the plane will fly 3 times, because 3 minutes, 3 times 3.3, which is 9.9 miles. Because we've got, let's look at the units again. We've got 3.3 miles per minute, and we're multiplying by 3 minutes. So the minutes divide out and we're left with miles. So that means our side C of our triangle is 9.9 miles. And now we're in a great shape to find A and B in miles. And I think they say, oh, nearest tenth of a mile. Okay. Well, what trig function involves this angle of 15 degrees, the hypotenuse, and one of the other sides? Yes, excellent, excellent. So we know that the sine of 15 degrees will be opposite over hypotenuse, A over 9.9, and that the cosine of 15 degrees will be adjacent over hypotenuse, B over 9.9. And let's see. 15 sine, we get 0.2588. And the cosine, 15 cosine, we get 0.9659. 659. So now we can do everything. If I multiply both sides of the equation A over 9.9 equals 0.2588, if I multiply both sides of that by 9.9, I'll get A. Do you see it on the left here? The 9.9s divide out. So I've got 0.2588 times 9.9. So that means that the plane will descend 2.6 miles in 3 minutes. Let's see how far it goes horizontally. So we've got 0.9659 times 9.9. So the plane goes 9.6 miles horizontally. So we were able to take the cosine of 15 degrees times the hypotenuse and get the horizontal distance, and we were able to take the sine of 15 degrees times the hypotenuse to get the vertical distance. And just for fun, because it's just, it's fun, let's check our values for A, B, and C using the Pythagorean theorem. So let's see, A squared plus B squared is C squared. And C was 9.9. A was 2.6. And B was 9.6. Let's see. 2.6 squared is 6.76. 9.6 squared is 92.16. 9.9 squared is 98.01. And if we add 92.16 to 6.76, let's see, 6.76 plus 92.16, we get 98.92. And these are very close because we did loads of rounding. In real world problems, it only makes sense to round a lot because the measurements are not that exact. 15 degrees is probably not an exact value. And 200 miles per hour is probably also not an exact value. Okay, great. This is fun. Okay, when you're solving an application problem and you know the side links but no angles, then again, you carefully sketch the situation, label all the sides that you do know, and then use inverse trig functions to find what you're looking for. So in this example, we're given, let's see, we want to find the pitch of the roof. Pitch is the angle up, so it's like angle of elevation with respect to the base of the roof. If the roof is 6 feet high at the highest and 15 feet wide, and it's symmetric. So I'm going to draw the triangle that we're going to look at. It's 6 feet up, and it's only half of this distance. Well, half of 15 is 7.5. And the angle that I want, let's see, let's call that angle A. I want to find the measure of angle A. Well, what trig function involves the opposite side and the adjacent side? Yes, exactly right. I know that the tangent of A is equal to opposite over adjacent, which is 6 over 7.5. And let's see what 6 divided by 7.5 is. So 6 divided by 7.5, I get 0.8. So I've got that the tangent of A is 0.8, and I want to take the inverse tangent of both sides. On the left, the inverse tangent and the tangent cancel, and we're left with A. And on the right, let's see, I've got my 0.8, which I don't have to change. And I want to take the inverse tangent, so I'm going to tap on second, inverse tangent. And now I see that my angle is going to be, they said to the 10th of a degree, so 38.7 degrees. 38.7 degrees. I want y'all to do, let's see, where are we? I thought I had one before this one for y'all. That's not for y'all. Let's see. Well, I know I want you to do this problem with the roof. So you have a similar problem to the one we just did. The roof is 5.5 feet high, and the expanse of the roof is 18 feet across. So while y'all are doing that, I'm going to find the one that I know I skipped accidentally that I want y'all to do. I may just have to print it out again. So y'all work on that while I find this. Oh, here it is. Here it is. So I want you to do problem 16 and also problem 14. Let's see how we can do this. Problem 14 is find the vertical and horizontal distance to the nearest tenth of a mile that an airplane will travel in 3 minutes if it descends at an average speed of 175 miles per hour at an angle of depression of 14 degrees. And I went ahead and did a beginning sketch for y'all. And then we have this problem with the pitch. So I'm just gonna try, well, here's number 14. So go ahead and pause and write down that information. And then here's problem 16. Go ahead and pause and write down that information. Okay, great. Now plow forward. Bearings. In navigating and surveying, the term bearing is very often used. It has an angular relationship from a point of view of the north. So from point A to point B, the degree measure is the acute angle. Acute is less than 90. Let's write that down. Acute is less than 90 degrees. Obtuse is the other one. Is greater than 90 degrees. And right is equal to 90 degrees. Those are the three. So when we say the acute angle, we're talking about an angle less than 90 degrees. So the degree measure of the acute angle formed by the north-south ray. The bearing is denoted by north-south, followed by the angle, followed by east or west. And the easiest way to explain it is to do an example. So we want to find the bearings. Let's see, they already gave us the bearings from A to B. From A to B, well, I can see that if I'm going from A to B, I'm going up, so north, and I'm going to the right, so east. And it's 42 degrees with respect to the north-south line, and that's less than 90, so that works. So we would say that ray AB is north 42 degrees east, and ray BA, from B to A we're going down, so south. The angle will stay the same, and this time we're going to the left, so west. So do you see that bearings give you direction. And it's always exactly opposite if you're going in the opposite direction. So from A to B here in the second image, we're going up, so north. Let's see, so we've got, this is part B. We're looking at from A to B, we're going up, so north. The angle with respect to the north-south line is 74 degrees. And we're going to the left, so west. And that's what they have. If we're going from B to A, from B to A, we're going down, so south. The angle will always stay the same. And we're going from B to A, we're going to the right, so east. I want y'all to do this question 18, A to B and B to A for the two images shown. I'm going to let you pause and copy that down. Great. Let's find the following bearings. We want to do OC, AO, and OB. So let's first look at OC. This is always directional, starting with the point O, going toward the point C. So starting with the point O, going toward the point C, I can see I'm going south. I'm going down. The angle with respect to the vertical line is 40 degrees. And I'm going to the right, so east. All right, that was A. B is AO. So I'm going from A to O. From A to O, I'm going down, so south. Now they give us the angle with respect to the positive x-axis, but I need the angle with respect to the positive y-axis. Well, that's okay. We know that the whole quadrant is 90 degrees. 90 degrees minus 22 is going to be, well, that's 8. 8 minus 2 is 6. So 68 degrees. And from A to O, we're going left, so west. Now we're looking at O to B. So our ray is OB. From O to B, we're going up, so north. The angle that I want is the closest one between the north-south line, the y-axis, and this ray OB, but I don't have that. I have the whole first quadrant all the way over to B. So we know that 118 is the angle that we want plus 90. So if I subtract 90 degrees, because this entire first quadrant is 90 degrees, so we get 8. 11 minus 9 is 2. So this small inside angle is 28 degrees. So north, 28 degrees. From O to B is north. And we're going left, so west. And here are 3 problems for y'all to do with that same scenario. So I want you to do from O to A, from B to O, and from C to O. Okay, great. And a plane leaves an airport heading south 32 degrees west at 320 knots. Knots are nautical miles per hour, and we're going to denote nautical miles per hour as N space MI for miles divided by hours. Determine the nautical miles south and the number of nautical miles west that the plane flies in 1.2 hours. So I know their speed and I know the time. So the distance will be the speed times the time, and I don't have to remember that formula. I just need to write 320 nautical miles per hour. I have hours in the denominator here, so I need to multiply by hours to get the hours to divide out. 1.2 hours. Now the hours have divided out and I'm left with just nautical miles, which was the goal. And 320 times 1.2 is 384 nautical miles, and that's indicated here. So now we finally know the hypotenuse. We want to find the ray, the distance from A to B, and we want to find the distance from B to P. So let's see. We've got an angle here at the top. AB is adjacent to 32 degrees, and I know the hypotenuse. So cosine of 32 degrees, that's going to be adjacent over hypotenuse. Adjacent is AB. Hypotenuse is 384. And let's see what the cosine of 32 degrees is. Cosine of 32 degrees is 0.8480. And that equals AB divided by 384. So we're going to multiply both sides of this by 384 so that we get AB. That's what we're trying to find. Again, I'm rounding this to 4 decimal places, so I don't want to use that full value that the calculator gave me. There's what, 0.848 times 384, and we get that the distance from A to B is 325.6 nautical miles, and we'll round to the nearest whole mile. Okay, so this is going to be 326 nautical miles. 326 nautical miles. Well, now let's find the distance from B to P with respect to this angle 32. Oh, that's opposite. Okay, great. So we know that the sine of 32 degrees, that's opposite over hypotenuse. That's BP divided by 384. And let's see what the sine of 32 is. 0.5299. And if I multiply both sides by 384, On the right, I get the distance BP, and on the left, let's see what we get. 384 times 0.5299. We get that this distance is approximately 203 nautical miles. We're rounding to the nearest nautical mile. And now I just want to check by using the Pythagorean theorem. So I know a squared plus b squared is c squared. And the hypotenuse here is 384. And I'll just use the labeling that was on the problem. We've got 203 squared plus 326 squared. So, okay. 203 squared is 41,209. 326 squared is 106,276, and 384 squared is 147,456. So now I just have to add the two squares here. I've got 41,209 plus 106, 276, 106, 276 plus 41, 209. And we get 147, 485. And that's definitely close enough. That's very, very close. All right, the last problem that I want y'all to do is a situation very similar to the one that we just did together. A plane is leaving an airport at a heading of south 28 degrees west at 250 knots, or nautical miles per hour. Determine the number of nautical miles south and the number of nautical miles west that the plane will travel in 1.5 hours. Again, round to the nearest whole nautical mile, and don't forget to check your work at the end using the Pythagorean theorem. Well, I'll see y'all tomorrow. It's everything is going very quickly, but I hope you're having a great day, and I'll talk to you real soon. Bye.